Hello everyone, welcome back. Mr. Zebron here, Arimunta Zirislami Seminary Maths teacher. I will take you through the video series paper 1, the paper in which we don't use a calculator. And when I talk about paper 2, in that paper is when we need to use a calculator. Okay, so in this paper 1 video series, continuation, I'm not going to use a calculator because this is paper 1 Maths lower secondary checkpoint, right? So there we start. We ended here, as you can see. This is where we ended, and we're going to continue from this point of view. A hamster eats 2/7 of a bag of carrots each day. So we're going to write that for one day, hamster eats 2/7, okay? And then the question is, work out how many days it takes the hamster to eat 8 whole bags of carrots. Okay, so how many days? The question is, how many days does that take to eat the whole bag? Okay, so you're gonna put a question mark somewhere here. Okay, so you're going to put a question mark here, and then you're going to go ahead writing, work out how many days it takes the hamster to eat 8 whole bag of carrots. Okay, so from this setup, we're going to cross multiply, and then we're going to end in get up 8 times 1. So 8 times 1, the answer you get, you're going to divide by 2/7. 2/7. Now this setup looks confusing, so just do like this. 8 times 1 is 8. Now, instead of putting this over to mean division, just put this normal division, which is just a simplest symbol for division. So this will be 8 divided by 2/7. Okay. Right. So keep going. This is a whole number. So keep it over 1. And this becomes 8/1. And do a reciprocal of that. This will be times 7/2. Look across, yes, you can simplify by 2, 1, by 2, 4, and then multiply horizontally. 4 times 7 is 28. Over 1 times 1 is 1. Now this will be equal to 28. And the answer here will be 28 days. Okay, so I think that is very clear. And then we keep moving. We have the next question, which is on this slide here. Okay, the software is still loading a bit. Let us try to be patient for this. Okay. All right, so for those who are not aware, is that I have already uploaded video series number 1, and it's also talking about the same paper, which I'm doing right away. So if you have not watched the first video, please go ahead. Checking out that video has been uploaded on my YouTube channel through your WhatsApp group. Okay, so now the software is ready to go. So I have this question here. The diagram shows a fish tank. So this is a fish tank. The fish tank has a capacity of 60 liters. This fish tank has a capacity of 60 liters. Now, Lily uses a 2,000 milliliter jug to put water in the fish tank. Okay, she stops only when the water is 4 centimeters from the top. Okay, so Lily is putting water into this fish tank, and really gonna stop when the water reaches 4 centimeters from the top. 4 centimeters from the top. So what we are going to do is this 40 centimeters you can see here, this 40 centimeter is the whole fish tank. Now we need to calculate how deep that water that Lily is pouring into this fish tank, how deep that water is. It's not 40 centimeters, is depth of water that Lily puts into this tank. Depth of water will be equal to 40 centimeters minus 4 centimeters. That is the depth of water that Lily has poured into this fish tank. And this becomes 36 centimeters. So that is the depth of the water present in this fish tank after Lily has put water into it by using a 2000 milliliters jug. So now we want to calculate the volume of water that has been put inside by Lily. Okay, so what we're going to do is volume of water will be volume of water, because this takes the shape of a cuboid. So volume will be length times width times height. Now length will be 50, width will be 30 centimeter, but the height will not be 40. The height will be 40 centimeter minus 4, which is 36 centimeters. Why? Because the question says, the question says here, Lily stops when the water is 4 centimeters from the top. So how deep the water in the fish tank will not be 40, will be 40 minus 4. That will be 36, okay? Now the volume of water will be equal to, V for volume will be equal to length, which is 50 centimeters, times width, which is 30 centimeters, times height. As I said earlier, this will not be 40, will be 36 centimeters. Okay, so volume of water present in the fish tank is really stops. Volume will be 50 times 30 times 36. And you can go ahead calculating that, because this is a paper which you are not supposed to use a calculator. So you can go ahead multiplying that manually. And for sure, you're going to get volume equals to 54,000 centimeter cube. Okay. Now, all what you have to know is that centimeter cube and milliliters are the same. So if you get a volume of 54,000 centimeter cube, that is most likely to be the same thing, 54,000 milliliters. Mark my words, centimeter cube and milliliters are the same units, okay? So you find that in 1 centimeter cube, you have 1 milliliter. So centimeter cube and milliliters are quite the same, okay? Why should I consider that way? Is because you can see that Lily is using a 2000 milliliters jug to put water in the fish tank. Now she stops when the water is 4 centimeters from the top. So work out the number of jugs of water that Lily uses. So now we know that the volume that Lily puts into this fish tank, the volume in total of that water is 54,000. Now the question is, if Lily uses a jug a jug which capacity is 2000 milliliters. So the question here is work out the number of jugs of water that Lily uses. Okay, so we're gonna try setting up an equation that one jug is equal to 2000 milliliters. Now, how about 54,000, which is the total volume of water that has been put inside there? So how many jugs will be there? So you do this setup, and you're going to end up getting 54,000 times 1, 54,000 times 1. The answer you get, you need to divide by 2,000. So if you do this, you're going to end up getting the 2 zeros. These 3 zeros are going to cancel each other, and you're going to end up getting by 2, 1 by 2, 27. And the answer becomes 27 jugs. Okay, gonna get 27 jugs. So that is your final answer. So go ahead checking out using your own method. 54,000 times 1, the answer you get divided by 2,000. You're gonna end up getting 27 jugs. I hope that is clear. So let us keep going. We have this question here. Draw a ring to match each fraction to its percentage. To convert any fraction into percentage, simply take that fraction, for example, 1/4. You want to turn 1/4 into percentage. Take this fraction, multiply by 100%, and calculate this. You're going to end up getting something like 25%. And this has been shown as an example. Now let us do 7/20. So do the same thing. 7/20 multiplied by 100, and then simplify. This 0 goes with this 0. By 2, 1 by 2, 5. 7 times 5 equals 35. And then you're going to take a ruler, match 7 over 20, match this 7 over 20 to 35. So you're going to match this way. Okay. And then you do 17 over 50, the same thing, 17 over 50. You do times 100%. And then this 0 goes with that 0, 5, 1, 5, 2. 7 times 2 will be equal to 34. So you're going to take this and match to this. Okay. And lastly, try to do 6 over 15 multiply by 100%. We're going to do by 3, this is 2. By 3, this is 5. By 5, this is 1. By 5, this is 2, 0. Okay, so by 5, that's 20. Then you do 2 times 20 is 40. So this will be 40. And you're going to take 6 or 15, try to match that 6 or 15 to 40%. Okay, so I can see that every single fraction here has been matched to its corresponding percentage. So automatically, because we are left with one fraction and 1%, so automatically I don't have to waste time. Instead, I'm going to take 1 over 3, head it over to 33, 1 over 3%. And you can try to check out that. Okay. The next question is, write this ratio in its simplest form. We have 2.4. We have 2.4 meter ratio 45 centimeters. Okay. Now, since this is meter and this one is centimeters, you cannot start simplifying that ratio. What you are supposed to do is to change the bigger unit into the smaller unit, meaning change meter into centimeter. And we know that from King Henry daughter, blah, 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 we know that 1 meter equals to 100 centimeters. Okay, now how about 2.4 meter? This will equal to 2.4 times 100. You can use your manual multiplication, but you're going to end up getting 2.4 times 100. So you're going to get 2400. Then you have 1 decimal place here. So you're going to count 1 decimal place from the right, and you're going to end up getting 240.0. Cross out this, you're going to end up getting 240. Okay, so now you're good to go. This becomes 240. This time is not meter. Now this time is centimeter. So you're going to combine with 45 centimeters, of which you can see now the units are the same. Yeah, centimeter, centimeter. Now this ratio, after setting up same units, this one you can now simplify. So the first thing you have to do is cross out the centimeters. They are gone already. So you're going to have 240 ratio 45. And then think of the number which is dividing both these numbers. So this number is try 5. So by 5, this will be 9. And this will be by 5, 1 by 5. This will be put 4 there. So that will be 20, 48. Okay, you can try checking this. 48 times 5, that will be 40, that will be 20, 24. Okay, so now this becomes 48 ratio 9. Can you simplify this? I guess no, you can't simplify this. Can we check? By 3, you need to go by 3. Let me check. 48 divide by 3, 1, 3, 18. Yes, this by 3 will go. Is simply yes. That will be, you have to continue further. That by 3, so we have 48 ratio 9. By 3, this will be 16. And this will be 3. Can you keep going? By 2, by 3? No. I think the simplest form of that ratio will be equal to 16 ratio 3. The next question will be, I'm trying to move faster so that I can finish this worksheet. And then inshallah, next time I'm gonna I'm gonna try answering other questions that you have on the papers that I provided to you a few days ago. Okay, so this is question number 22. What does this question say? It says that Q is the reflection of P in the line x equal to 2. Q is the reflection of P. Q is a reflection of P in the line x equals 2. Work out the coordinates of Q. So the line x equals 2, this line x equal to 2, this line here is what we consider as to be the mirror line. Okay, so that x equal to 2 is the so-called mirror line. So now this mirror line, they're saying that Q is a reflection of P. Okay, so if this is point P, and this is your mirror line, so you're gonna count the number of boxes from the mirror line to where point P is. So you're gonna count, you have how many boxes from the mirror line? You have 1, 2, 3 boxes. Now we're going to count the same 3 boxes on the other side of the mirror, right? So you have 1, 2, 3. So count on the other side. You're going to have the same 3 boxes. 1, 2, 3. So you mark that this is where point Q will be. And then let me check quickly. 1, 2, 3. 1, 2, 3 boxes. So Q will be here. Now, what are the coordinates of Q? What are the coordinates of Q? We're going to start recording from the x-axis. So that is -1. Comma, this is -2. So the coordinates of Q will be -1, -2. So this will be -1, there's a comma already, so -2, right? So I hope that is clear. You can check out if there's any problem, please come back to me. I will not hesitate to help, okay? So the next question is, a sequence begins with a number 3, -6, 12, -24, 48. The question comes to be, write down the term-to-term rule for this sequence. If I can check that from 3 to -6, from 3 to -6 is like, there are 2 possibilities here. Somebody can say from 3 to -6, somebody can say 3 adding -9. 3 plus -9, the answer will be -6. Okay, but let me check, is this adding -9, is it going to work throughout? Because in order for you to confirm that it is a correct term-to-term rule, you must check in the next step if adding -9 to -6 will also give you 12. Let us try. -6 adding -9, this will be positives and negative will be negative. So you're going to have -6 there, you're going to have 9 there. So -6, -9, this will be -15, but we're supposed to get 12. So in that case, adding -9 is not the correct term-to-term rule. It's not the correct term-to-term rule. So then we have to figure out adding -9 is not correct. So let us figure out another term-to-term rule. From 3 to -6, another one can say multiply by -2. Okay, now let us check. If we multiply by -2, can we do -6 times -2? Yes, multiply by -2, meaning -6 times -2. Do you get 12? Yes, negative to negative, positive. 6 times 2 is 12. So that is correct. Now let us keep going. From 12 to -24, try to multiply again by -2. So 12 times -2, yes, you're going to get -24. Try multiplying by -2. So this -2, should you get 48? Yes, we do. So here, the term-to-term rule for this sequence will be multiply by -2. Multiply by -2. Okay, and you get your 1 mark there. The next question is write down the next 2 terms. Okay, we're gonna get the next 2 terms by maintaining the multiplication of -2 throughout. So this will be 48 times -2. This will be -96. Okay, you can help checking that, but this will be -96 because by 2, yes, -96, and then you do -96 times -2. So you can try. You can try pausing this video and then multiply what you're gonna get. Okay. So from -96 multiplied by -2, this will be Positives and negative. Okay, negative to negative will be positive, and you're going to end up getting 12 there, 192. So 192 will be the next term. So you're going to write here the first one will be negative 96, and the second one will be positive 192. Okay. So far, so good. So there we go. We have this question, yeah. The question says, draw a ring around all the statements that are examples of district data. Now, what do you remember about district data? What did I say? You can pause this video, try to remember actually what does district means. Okay, you can try to pause this video and try to think, what does district data mean? So we say the term district means counting. Any data that you observe to get from any data that you collect by counting, that is district data. Now, the reverse or the opposite of district is continuous. Okay, continuous. Okay, what does continuous mean? Continuous data is the data that we collect after measuring. You see? So these are two different terminologies. District, counting, continuous, measuring. Okay, now let us see which one is which. Draw a ring around all the statements that are examples of district data, but district is counting, continuous is measuring. Okay. Any mark out of 10 on a test. If a teacher gives a test and then start awarding marks, does that teacher count or does that teacher measure the marks? So any mark out of 10 on a test is basically continuous because, any mark that we collect from any test is not continuous, rather it's counting, or which is basically district data. So draw a ring around the statement that are examples of districts. So I'm gonna go for this. This will be district. Why? We do counting and we don't measure, okay? Time taken to run a marathon, time taken. You have to do measurement, take a stopwatch, ask somebody to run marathon, and then you check out their stopwatch, that is measuring. So time taken to run a marathon is not district, it will be continuous, okay? Mass of a bag, if you want to measure masses of people, masses of children, masses, that is all about measuring. Average speed, this is all about measuring. Okay, number of books sold. This is for you to get number of books sold, you need to count basically. So you cannot measure the number of books. So if I ask you, how many books do you have in your home library? You cannot say, wait, I have to go and measure. Rather, you have to go and count. Okay, so anything that is associated with counting, that is district, and anything or any data that is associated with continuous. I mean, anything that is associated with measuring, that is continuous, and anything that is associated with counting, that is district. Okay, so let me check quickly. Mark out of 10, yes, that will be district because we have to count. Time taken to run a marathon, no, that cannot be district. Drawing around all the statements that are examples of district. Okay, mass of a bag that we need to measure. Average speed, that is all about measuring. Okay, so here is a calculation. We are given this calculation, which is a very beautiful calculation that says 48 times 23, that equals 1104. Now we're going to use this calculation to answer these questions. Okay, look at this. The calculation given is 48 times 23 equals 1104. Surprisingly, the question that they want us to work out is containing a 24. So how do we manipulate this 23 to become 24? Okay, well, this will be 48 times 24. This is the same as 48 times. In place of 24, I'm going to take this 23. I'm going to take this 23 that we have in the calculation to be used. I'm going to take that 23. To this 23, I'm going to add 1 and put it in brackets. That is your 24. So this is 48, which is this number. But in place of 24, in the calculation, I don't have any 24. So I have to take 23 to that 23, I'm going to add 1. Then when I reach here, there is a small thing I have to do is opening the brackets by multiplying this number outside. You multiply it here, and also you multiply that number there. So this will be 48 times 23. But mind you, 48 times 23, 48 times 23, if you can check, 48 times 23, this is the calculation we have, 48 times 23, guess what? That is 1104. So I'm gonna write here, 1104. Okay, so keep going. This is 48 times 23, because I'm opening the brackets here, 48 times 23, then plus, again, I'm gonna take this number outside, which is 48 times 1 here. So I'm gonna get 48 times 1 is 48. But guess what? 48 times 23, we already know that 48 times 23 from the given calculation is 1104. Okay, to this, I'm gonna add 48. And when I take 1104 plus 48, let's do it here, 1104 plus 48, this will give you in turn 4 plus 8, 12, carry 1, this is 5, 1, 1. So the answer is 1152. This is your answer. Now, majority of students, when they get this question, which says use the calculation to answer the given questions, what they do, they go ahead ignoring the calculation to be used, and then they start multiplying this vertically like in primary school, and then they end up losing. Marks. But then they're gonna come to complain in turn that, but sir, my answer is correct. Yes, your answer is correct, but you did not use the calculation given. So you must use the calculation given. All right, so the next question is this question here, 4.8 times 0.23. So what I'm gonna do is that in the given calculation, I don't have any decimal, but here I do have decimals. So what I'm gonna do is convert all these decimals into fractions. So you're gonna have 4.8 becomes 48, but it will be over 10, then times 0.23 as a fraction will be 23 over 100, okay? And then multiply the bottom and multiply the bottom, multiply these bottoms and multiply the tops. So you're gonna have 48 times 23. Then down there, you're gonna have 10 times 100. But guess what? What is 48 times 23? Don't use a calculator. Do not even use your manual multiplication. Look at the calculation given. Here is a calculation. 48 times 23 equals 1104. So you're gonna go ahead copying this answer, that 48 times 23, 48 times 23 will be 1104. Then over 10 times 100, this is equal to putting zeros next to each other. So it will be 1,000. Now, guess what? Any number divided by 1,000 requires you to count 3 decimal places from the right-hand side going left. And then you have your answer, which is 1.104. And this becomes your final answer. Okay, so let me do this one. 1104, which is this answer here, 1104, divide by 2.3. Guess what? Look at this. 48 times 23 equals 1104. Just look at this. 2 times 6 is 12, yeah? So 2 times 6 is 12. What if I try manipulating this? What if I do 12 divided by 6? What do you guess the answer will be? 2 times 6 equals 12. What if I do 12 divided by 6? That will be this answer here. Or what if I do 12, what if I do 12 divided by 6? Sorry, 12 divided by 6 then. What if I do 12 divided by 2? 12 divided by 2 will be this answer here, okay? I think you understood the logic there. So now let us go back to my calculation, which I'm supposed to work out. Okay, so I have all this. I have this one, 1104 divided by 2.3. So I'm gonna change this decimal to be a fraction. So we have 1104 divided by, this will be 2.3 as a fraction. It will be 23 over 10. It will be 23 over 10. So this decimal is out. It's gone. Now, this is, keep this over 1, and then you have this thing, 1104 over 1, then do reciprocal, yeah, times 10, and then 23 comes down. You see that? Now I will have 1104 times 10, which I'm going to write this way, 1104 times 10. Don't do this calculation. 1104 times 10, don't do that. Just write times 10 like this at the very far point like that. And then down, you're going to have 1 times 23. That is 1 times 23. That is equal to 23. Now, what do you see? You can see that 1104 divided by 23. What is that? Can you try guessing the answer? Look at this. 48 times 23 equals 1104. What if I do 1104 divided by 23? 1104 divided by 23. What do you think that will be equal to? I think you said 48. Okay. You can try to check out with that. And if you don't understand the logic, then you can come back to me. So 1104 divided by 23. 1104 divided by 23 will equal 48. Okay. So continue from here. 1104 divided by 23. This whole thing will be equal to 48. So this will be equal to 48. Now, when you finally multiply by 10, guess what? 48 times 10, this answer will be 48. 48, this will be your answer. Okay. I hope you got the logic. Oh, sorry, this question was very lengthy, and because it uses a lot of logic to work it out. And let me check. Okay, I'm gonna have to finish this paper basically. Okay. Look at the numbers in the box. We have these numbers here. Draw a ring around all the irrational numbers, or irrational numbers. Okay, what are the irrational numbers? Irrational numbers are the numbers which cannot be written as a fraction. They cannot be written as a fraction. And all recurring decimals are not irrational numbers. So an irrational number is any number that you can't put in the form of a fraction. So let us try to analyze a few of them. So we have this symbol pi. Draw a ring around all irrational numbers. So we have this pi here. Is an irrational number. 2 or 5. What is an irrational number? An irrational number is any number that cannot be put in a form of a fraction. So pi, some people will start saying pi is 22 over 7. No, pi is not 22 over 7. Pi is an approximate of 22 over 7. And some other people will say 3.14 is their pi. Pi is not 3.14. This is just an approximation of pi. Okay, so pi as pi can run forever, you know, will not terminate, will not even recur, will keep going. So pi is an example of a irrational number. What about 2 over 5? This is already a fraction, so irrational number cannot be a fraction. Can also be, irrational number cannot be a fraction, and also cannot be a decimal like this, because this decimal can be a fraction. Cube root of 8. Cube root of 8 is the same as which number times itself 3 times gives you 8. Cube root of 8 is 2. And 2 can be put as a fraction. So cube root of 8 is not irrational. Basically, square root of 8 is irrational because this cannot be a fraction. If you use a calculator, what is square root of 8? You're going to get something like almost 2 point, yes, 2 point blah, blah, a lot of numbers there. 1.5, this is any decimal that is repeating. Let me try to clarify. If you have 1.5 with a dot up there, it means 1.555. That means a 5 keeps repeating forever. That is what it means. Okay, so if we have 1.5 with a dot up there, it means that. And this is not irrational because any repeating decimal can be put as a fraction. Okay. So the irrational numbers will be pi and square root of 8. The remaining others are not irrationals. Okay, so the next question will be this question here. Okay, this question here. Use numbers from the list to complete the statements. Okay. You may use a number more than once. Okay, that's far better. The square numbers are, is 2 a square number? No. 9 is a square number. 14 is a square number? No. 20, 35, 36 is a square number. Because what does a square number mean? A square number, that means you can find its square root. What is square root of 9? That is 3. What is the square root of 36? That is 6. So a square number is any number that has its square root. Okay, so 9 and 36, those are square numbers. The factors of 18 are those numbers which are divisible by 18 and 18 itself. So the factors of 18 will be 2 is divisible by 18, 9, done. Okay. All right. The multiples of 4, are 4, then keep adding 4. So you have 4, 8, 12, and so on. So let us check. Do you have a 4 here? No. Do we have multiples? Yes, 20 will be multiples of 4. 20 will be. Do we have another? Yes, 36 will be. 36 will be a multiple of 4. All right. The diagram shows a pair of parallel lines. GH and JK are parallel lines. Okay. What do they do, these parallel lines? EF, this line here, is a straight line that crosses GH at X. It crosses GH at X, and it crosses JK at Y on the diagram. Okay. Now label with the letter. On the diagram, label with the letter A, the angle that is alternate to angle GXY. On the diagram, label with the letter A, the angle that is alternate to angle GXY. Okay. GXY, they mean this angle is alternate to this angle down there. And for alternate angles, we look for a letter which is forming something like Z, and you do have a Z. So for alternate angles, you're gonna go ahead and look for Z. So this angle here is alternate to this angle, and you're gonna go ahead labeling that angle as A, okay? So for alternate angles, look for letter Z, all right? So this angle here is alternate to that angle, and you're gonna label that angle as A. So they said on the diagram, label with the letter A, the angle that is alternate to angle GXY. GXY, which is this angle here, is alternate to this angle. Now you go ahead labeling that angle as A, okay? On the diagram, label with the letter C, the angle that is corresponding to. Corresponding, we look for letter F, whereas alternate, we look for letter Z. Okay, corresponding to angle GXY. Okay, so let me check closely. Corresponding, we look for letter F, GXY. So we have GXY, this angle here. I have to trace something like F. I think you can see clearly letter F. Can you see it? I think you said yes. So that is letter F. So this angle here, letter F, yes, we do. So this angle here will be equal to this angle, meaning they are corresponding angles. Okay. So we're gonna go ahead and labeling that as C. Okay, we're gonna go ahead and labeling that as C. So we're gonna put C somewhere here. Okay, so that is corresponding angles. That angle will be equal to that angle. So if this angle is say maybe 20 degrees, for example, even this down angle will be 20 degrees. Okay, I hope that is very clear. So now let me write quickly. So we're gonna have this angle is alternate to this angle and label that angle as A. This angle will be corresponding to this angle. And we're gonna go ahead labeling that angle as C. See? All right, so that is clearly your F, right? Keep going, label with the letter C the angle that is corresponding to angle J. All right, cube root, work out the cube root of -64. Cube root means, is there any number that you can multiply by itself 3 times, and then you end up getting -64? That number will be -4. How? -4 times -4 times -4. What do you see? Negative times negative is positive. Positive times negative is negative. What is 4 times 4 times 4? That will be 64. Okay. So the cube root of -64 will be equal to -4. You get your tick there. I'm almost finishing. It's almost an hour past. Okay. The next part is this question here. Okay. This is part of the net of a cuboid. Okay. This is part. A cuboid basically has 6 faces. So if this is a net of a cuboid, we expect to have 6 faces. Okay. So we have this face here, and you have this face there. So we have a total of 1, 2, 3, 4, 5 faces. So the remaining, the 6th face is the 6th face is missing there. So I'm gonna try to get my tool here and draw. Let us see. Let us try to see which face is missing. Okay. This face here is the same as this face down there. This face, which is one by one, this face here is the same as this face. So the missing face is what do we call the top face? And that top face can be either drawn somewhere here, and it is a 1 by 2. Okay. You can draw that face there, or you can draw that face here. Okay. You can either draw this face, yes, you can either draw that face here or somewhere here. Okay, but not here. And not even here, because if you do that, I don't think if that net will be able to close. Okay, because if you fold this net, this side, I mean this face here and that face will make like something like walls, and this one will come back here, and this one will go there. So that side will come and match that. So you have to draw that face either here or here, nothing else. So I'm gonna put it here. Okay, and this makes a total of 1, 2, 3, 4, 5, 6 faces. All right, the next question is this question here. Complete the calculation. 0.9 times 4, 0.9 times 4. Simply do 9 times 4 is 36. And then you have 1 decimal point. So you have 1 decimal place. You're going to have 3.6 there. You're going to have 3.6. 3.6. A certain number times 7 equals 2.8. So there's a missing number here. So what do you do? Just take this times 7, then do the reverse of that. So you're going to have 2.8 divided by 7. And this will give you 0, 0, 2, 8, 4. And then you're going to have 0 there. So the answer here is 0.4. Lastly, you have a map has a scale of. What is the definition of the scale? Scale is distance on a map over the so-called distance on the ground, which we call it actual distance. Okay, so this scale is this given here, which is given as a ratio. So you're going to write this ratio as a fraction. So just write this fraction here. 1:2,000, 1:200,000 will be 1 over 200,000. So just do this setup. That scale is distance on a map of actual distance. And that scale, go ahead writing that scale as a fraction, not a ratio. So the distance between two towns on the map is 5.5. Okay, so we are given the distance on the map. So instead of writing this word, distance on a map, copy that number. The distance on a map is 5.5. It's 5.5 centimeter. Find the actual distance. Okay, the actual distance is unknown. So go ahead putting a letter here. Okay, go ahead putting a letter. That is X. Okay. So you just go ahead putting, consider actual distance as something missing. And then just put 1 over 200,000. Okay, 200,000. Now from here, just cross multiply. So you're going to have X times 1 is X. Sorry for the pen is like skipping some signals. So X times 1 is X equals to 5.5 times 200,000. So you have 5.5 centimeters. 5.5 centimeters times 200,000. So when you do this calculation, 5.5 times 200,000, 5.5 times 200,000. If you do that manually, you're going to end up getting 1100, 1100, 000. So you're going to have 11, then double zeros, then triple zeros. Okay. So, but that will be in centimeters. That answer, that actual distance will be in centimeters. Now, guess what? They said, give your answer in kilometers. Okay, now you repeat the process. From King Henry Daughter, we know that 1 kilometer equals to 100,000 centimeters. How about 11,000,123 centimeters will equal to how many kilometers? Cross multiply. So this will be 1, this number here, times 1, then the answer you get divided by 100,000. So 1 kilometer equals to 100,000 centimeters. How about all this? So you're going to have 11, 1, 2, 1, 2, 3, divide by this number times 1 is the same number. Now you're going to have to divide by 100,000. So you can cross out this, all these 5 zeros, cross out, and the answer will be 11 kilometers. Okay. So this is your actual distance. That your actual distance will be equal to 11 kilometers. Okay. The last part, I think I'm going to finish this paper right away. I take to show if each of these statements is true or false. One has been done for you. 1 meter equals to 100 centimeters. That is true from King Henry Daughter. 1 millimeter equals to 0.01 centimeter. Let's try to check. 1 millimeter. Okay. 1 centimeter equals to 100. Sorry. 1 centimeter equals to 10 millimeters. So how about 1 millimeters will be equal to how much? 1 times 1 is 1, divide by 10. So this will be equal to 0.1. That will be equal to 0.1 centimeter. But here you are given 1 millimeter equals to 0.01. So that is false. How about this? 1 kilogram equals to this fraction. This is 1 over 1,000 grams. Is this correct? Let us try to see. 1 kilogram equals to 1,000 grams. This is what we know. But here it is 1 kilogram equals to 1 over 1,000. No, this is not correct. That is false. 1 kilogram equals to 1,000 grams and not 1 over 1,000 grams. Okay, that is false. 1 ton equals to 1,000 kilograms. That is true. Okay, that is true. 1 ton equals to 1,000 kilograms. Using a straight edge. When I say a straight edge, I mean a ruler. So that is a ruler. So use a straight edge, meaning a ruler, and compasses only to construct an equilateral triangle ABC And the side AB has been drawn for you. And do not rub out your constructions line, your constructions axis. So this is very simple. What you need to do is to use a ruler and a compass. So I'm gonna take out my compass and try to show you. And remember, these compasses and the rulers I use here, these are virtual tools. They are not as real as you think. These are just for demonstration. So you take a compass like this. This is a compass, okay? This is a compass. Can you see this? This is my compass. So this compass, set it this way, set it that way, and then put that compass somewhere here. And then open wide this compass. Open wide this compass. Sorry, open wide this compass. You're gonna open wide like this until you hit that point. You see that? It's very easy to construct. You see? So set up a compass like this, open wide, end to end of the given line. And then turn your compass, so that after turning your compass, so that you can draw an arc, draw an arc somewhere there. Can you see? What I'm drawing here is known as an arc. It's known as an arc. Then do not disturb your compass. Just lift it and put it here. Put it on the other end, so that you can now come and draw to cut the previous arc. Can you see that? Cut the previous arc. Then after setting that like that way, then take your ruler, connect this point, connect this point here, connect this point to this point of intersection of two arcs. Can you see that? And then connect this point here to this point of intersection of two arcs. And that is your equilateral triangle. The triangle you see here is what we call an equilateral triangle. And how do you know that this is equilateral triangle? We know that this is equilateral triangle when we take our ruler and try to measure these sides. And if you take your ruler, measure this side from here to here, if you get like 6 point something, you're gonna get the same 6 point something throughout all the sides. So this is what we call the equilateral triangle, construction of equilateral triangle. Okay, hope that is clear. Do not remove these arcs. Do not remove those arcs. Okay, just leave them like that. Okay, then find the value of 4 minus. This is an equation, so I'm gonna do it as follows. Find the value of 4 minus 3x over x plus 8 when x is 2. Oh, okay, this is not an equation, it's an expression when x is 2. So I'm gonna write 4 minus 3x. So 3 times x is 2. Okay, 4 minus 3x over x, but my x is 2. Then later I'm gonna need to add 8. So I need to do this calculation. 4 minus 3 times 2 is 6 over 2. Later, I'm going to add 8. 4 minus 6 is 4 minus 6. This is negative 2. 4 minus 6, that is negative 2. This is negative 2. Divide by 2. Then later, I'm going to add 8. Okay. Negative 2 divided by 2. Negative divided by positive is negative. So 2 divided by 2 is 1. Add 8. Now here you have to swap. That will be 8 minus 1, and that will equal 7. See that? That is your answer. Draw a ring around each number that is common multiple of 3. Common multiple of 3. Meaning check, is 120 divisible by both 3 and 4? Let's check. 120 divided by 3 is 40. 120 divided by 4 is 30. So draw a ring. This is a common multiple of 120. Try to check 342. 342 divided by 3. Is it possible? 342 divided by 3. Okay, so 342 divided by 3, yes, you're gonna get a whole number. How about 342? 342 divided by 4. Can you pause the video and try that? Okay, so 342 divided by 4, that will give you a decimal. So this is not a common multiple of 3 and 4. Can you try checking 998? 998 divided by 3? You should get a whole number. If you get a fraction, then if you get a decimal, then that is not. Try 384. Okay, try 384. You can pause this video and try to check. Is it divisible by 3? If you get a whole number, then that is divisible. If you don't get a whole number, then that is not a common multiple. So you can try to pause this video and try to do that. Okay, so try checking. This will be how 384 divided by 3. This will be 1, this will be 3, 8, this will be 2, 6, this will be 24, this will be 6. So it's divisible. How about by 4? 384 divided by 4. This will be 38 divided by 4. That will be by 9. This will be 36. 224. That will be 6. 96. Okay. So it is this number and that number. Those are common multiples. How about 342? Try to check. But it should be getting you a whole number, not a decimal. Okay. The last slide, which is the last page. Quickly, a rectangle has an area. So we are given a rectangle and we don't know the length. So the length is x and the width is y. Now a rectangle has an area, meaning length times width. Area of any rectangle is length times width. Now area is 8, but the length is x times the width is y. So 8 equals to length times width, which is xy. Okay, so you have this equation that you have that equation, which is 8 equals to x times y, which is xy. Okay, try to put this equation in a box. Very important. Now the sides of the rectangle are enlarged by a scale factor of 3. Okay, this rectangle has been enlarged, meaning take this x multiplied by 3, it becomes 3x, and the length becomes as long as that by 3 times. Okay, and this width has been multiplied by a scale factor, which is 3. So you're gonna look longer than previous, so it becomes 3y. So you're gonna have a rectangle which is huge as that. Can you try finding its area, the area of the new rectangle? So the area here will be length times width. This time my length has changed 3 times than previous, times the width has been changed. It has been 3 times than previous, so 3y. So what is the area for this? Area will be equal to 3x times 3y. This will be 9xy. This will be 3 times 3 is 9, x times y is xy. But guess what? xy is 8. Can you see this? xy is 8. So in the place of xy, I'm going to write 8. So this becomes area equals to 9 times xy. Xy, I got it. Xy is 8. So I'm going to multiply by 8. So my area will be equal to 9 times 8, and that will be equal to 72. And 72 will be your answer here. Okay? That's small logic, simple question, and then you're good to go. Lastly, okay, I'm almost there. The function y equals to x minus 3 square can be represented by this function machine, that you have the input, then to this input, which is x, subtract 3, and after subtracting 3, then square, and you get your output. Find the output if the input is -1. Okay, -1 is your input. Now input -1 to this function machine. So -1 minus 3, -1 minus 3. The answer you get, then is square. The answer you get, then you square that. Okay, do -1 minus 3. This is -4. This answer squared. To square means -4 times -4. That is what it means. And the answer becomes positive 16. So here we're going to go ahead and write 16. Now here comes the next question. Find the 2 inputs that give an output of 9. Oh, okay. I have to find 2 inputs that when I put them here, I'm going to end up getting an output of 9. So let us try input. Let's try to input. Okay. Be careful with this. Be careful with this. Anything that should come here when you square should give you an output of 9. What is that? 3 squared. 3 squared means 3 times 3, which is 9. You see? So I'm going to put a number here, which when I subtract 3 here, and then later square, I'm going to end up getting an output of 9. So let us try 0. Let's try to input 0 here. So 0, input 0 to this function machine is 0 as your input. It will be 0 minus 3. Okay. Then later square this. Then later square this. Let's try to compute if this is going to give us 9. 0 minus 3. This 0 is nothing. So we're going to cross it out. You're going to end up getting -3 square. What is -3 square? We end up giving you -3 times -3. And that is negative is positive. 3 times 3 is 9. So the first input will be 0. Another input, make sure that it should be giving you 3, because 3 squared is what gives you 9. So try to input 6 here. What is 6? Then minus 3. What is 6 minus 3? 6 minus 3 is 3. What is 3 squared? 3 squared is 9. So the next input will be 6. We're going to input 6 there. 6 minus 3 is 3. 3 squared is 9. See that? Simple logic, simple question. Lastly, write the name of a 3-dimensional shape that has 2 faces. Can you try to guess any 3-dimensional that has only 2 faces, but one of which is curved? Can you try pausing this video and try to guess? What is that? I think you said cone. Okay. Try to check a 3-dimensional shape which has 2 faces, because a cone is looking to be like this. So it has this part here, which is circular. Okay. There's this part here, which is a circle. And it has got that face, which we call it lateral face, or curved face. Okay. So I hope we said cone. Lastly, convert 160 kilometers into miles. 160 kilometers into miles. You're going to multiply by 5 over 8. And then you simplify this by 8, 1 by 8. That will be 20. 20 times 5, 20 times 5. That will be equal to 100. And that's all. So 160 kilometers is only 100 miles. Okay. So until next time, Zabron here, a maths teacher at Alimunta's Islamic Seminary. Bye-bye for now. Sorry for the very long video, but I have to prolong this video so that I finish this worksheet. We call it Paper 1 Practice for Lower Secondary. And when I say Paper 1, I mean no calculator. And when I say Paper 2 for Lower Secondary, I mean Paper 2 is a paper which you need to attempt it by using a calculator. Paper 2 for calculator, Paper 1 for not using a calculator. Bye-bye for now. Until next time, stay tuned. I'll be back. Bye.